Hey guys, this reading is going to be from your Blue Coach book, page 33 to page 35. Questions going on to page 36. If you have your Blue book, then you don't really need to listen to this. Or if you just want to hear me read it to you, you are more than welcome to listen to this. This is going to be posted in your Canvas. And one of the assignments for this module is for you to complete the questions that are at the end of this section. So if you don't need to hear me read to you, if you just want to go ahead and read it on your own, that is more than fine. I will actually also just link the reading in there. But if you want to hear me read it to you, I will read it to you as well. All right, so it says here chemical reactions and the conservation of mass. The words that we're looking for here are reactant, product, chemical equation, coefficient, law of conservation of mass. Getting the idea. A puddle of water evaporating and rust forming on metal are both examples of changes in matter. As you have learned, water evaporating is a physical change. Rust forms through a chemical change. In both types of changes, the amount of matter remains the same. Matter is neither created nor destroyed, even when a new substance is formed. Recall that a chemical reaction is a process in which elements and compounds combine to form new substances. For example, iron oxide, Fe2O3, is a compound you know as rust. The formation of iron oxide, it is an example of a chemical change. Iron oxide forms when iron, Fe, reacts with oxygen gas, O2, in the air. This reaction can be shown as a word equation. The arrows in the equation read as produces or yields. So here we have iron plus oxygen yields or produces iron oxide, which is rust. In this reaction, iron and oxygen are the reactants. A reactant is a substance that is present at the beginning of a chemical reaction. Reactants are always shown to the left of the arrow. Iron oxide is the product of the reaction. A product is a substance that is produced during a chemical reaction. Products are always written to the right of the arrow. So going back, everything to the left is known as a reactant. Everything to the right is known as a product. And this little arrow in the middle, that's a yield sign. So iron and oxygen are the reactants. That's what you start off with. And then the chemical equation or the chemical reaction happens and yields or makes iron oxide. Okay. The word equation above can be written as a chemical formula. A chemical equation describes the chemical reaction using chemical formulas, subscripts, and coefficients. A coefficient is the number written before a chemical formula to show how many atoms or molecules of that substance are involved in the reaction. The equation for rust formation is 4Fe plus 3O2 yields 2Fe2O3. That's a lot, right? Okay, so what this is saying is your coefficient, that's going to tell you how many atoms there actually are of iron. So there's 4 irons here, and there's going to be 6 oxygens here because it's telling you there are 3 O2 atoms. So 2 times 3 is 6, yields 2 Fe2O3. Okay, the reactants are 4 iron atoms and 3 molecules of oxygen gas. Each molecule of oxygen gas is made up of 2 oxygen atoms. Since the reactants include 3 oxygen molecules, there are a total of 6 oxygen atoms in the reactant. The product of this reaction is iron oxide. 2 molecules of iron oxide form. Each molecule has the formula Fe2O3. On to page 34. The formula Fe2O3 shows that a molecule of iron oxide contains 2 iron atoms and 3 oxygen atoms. Since there are 2 molecules of iron oxide and the product contains a total of 4 iron atoms and 6 oxygen atoms, if you compare this to the number of iron atoms and oxygen atoms in the reactants, you will find the numbers are the same. This means that the chemical equation is balanced. To find out if an equation is balanced, find these steps or follow these steps. 1, make sure the reactants in the products contain the same number of elements. 2, count the number of atoms and of each element in the reactants. Remember to multiply the coefficient by the subscript if there is one. Count the number of atoms of each element in the product. Check these numbers to see if they are equal. If they are, then it's balanced. It may help you to make a chart to compare the numbers. The chart below shows the equation of the rust formation is balanced. Okay, so this is what I do. I literally do something like this. I draw a little line right here. Let's see if it's going to let me. It's not going to let me draw on it. But I literally make a line wherever the yield is. And I write out, so I have Fe, so I have iron and I have oxygen. On this side I have iron and I have oxygen, and I literally count out how many of each. So very much like this. Okay, so this equals would be your yield sign. You count up, there are 4 irons here. There are, it says 2, that's my coefficient, and then 2 for my subscript. So 2 times 2 is 4. That means I have 4 here. And then 3 times 2 is 6, and then 2 times 3 is 6. So I have 6 oxygen atoms. All right, so that is the gist of a chemical equation. You'll see more of that. I know that was probably extremely confusing for you. All right, so the law of conservation of mass. When a log on a campfire burns, most of the log seems to disappear. You see only a small amount of ash left behind. You might think that most of the matter of the log is destroyed when it burns. However, in a chemical reaction, matter is not created or destroyed. In the 1700s, a French chemist named Antoine Lavoisier, I think that's how you say it, conducted experiments to prove this concept. Lavoisier measured the masses of the reactants and products in the reaction. He discovered that in any reaction, the total mass of the reactants is always the same as the total mass of the products. This discovery expressed in the law of conservation of mass. According to this law, matter is neither created nor destroyed during a chemical change. You've seen something like this before. It's just like with the conservation of energy. Energy cannot be created nor destroyed, and matter and mass cannot be created nor destroyed in a chemical reaction. So wherever you start with, you're going to end with, it's just going to be mixed around. Ooh. Sorry, kids. Let me shrink that for you. Sorry about that. I'm just going to push myself further in the corner. Okay. All right. Next page. Page 35. The diagram below shows a chemical reaction that took place in a closed container. So we're going to call that a closed system. The reactants were kept apart until the stopper was placed in the neck of the flask. The flask was tilted to allow the reactant in the test tube to mix with the other reactant. Remember, the reactants are like, if I'm baking, those are going to be my ingredients, what I start with, right? So my reactant. So I have a reactant here in the bottom, and I have a reactant liquid here, and I put a stopper on the very, very top of it. And then what they're saying is they tilted it to let this liquid out of this test tube into this flask here so that both of the liquids, both of the reactants interacted with each other. Okay? A yellow precipitate was formed, okay? Which shows that a chemical reaction took place. However, the total mass did not change. This result supports the law of conservation of mass. So even though a chemical reaction took place, you actually have the masses are going to be the same for both. In the investigation described above, a flask was sealed with a stopper. A sealed flask is an example of a closed system. No matter can enter a closed system and no matter can escape. It is important to study a chemical reaction in a closed system. This allows you to show that the mass of the products equals the mass of the reactants. A log burning on a campfire is not inside a closed system. The mass of the gases released by a burning log cannot be measured. So the conservation of mass cannot be shown. However, mass is still conserved. So when the smoke goes up, all the little particulate matter that goes up, all the gases that escape, if I were able to capture that and bring it back down and put it into the log itself, then you would see the mass would still be the same. All right, so I'm going to have you in your assignment, you're going to have to tell me how a chemical equation is compared to shuffling a deck of cards. You're also going to have to answer these questions for me. According to the law of conservation of mass, which of the following is a true statement? Examine the following chemical equation for number 2 and show which shows only the reactants. So these are only like the ingredients, right? Which shows only the reactants in one product. How many H, which would be hydrogen, atoms must be present in the second one, in the second product that is formed? So if what this is saying is figure out how many hydrogens over here. If my hydrogen, how many hydrogens would I have to have on my product side to make it equal? Okay. And then number 3, which one is not balanced? Okay. All right, kids. See you later.